Hi everyone, I am Dr. A. Prasanna, working as Assistant Professor in the Department of Chemistry, Vivivanni Perumal College for Women, Virudhunagar. Today, I am going to deal with the concept of aromaticity. Let me explain what are aromatic compounds first, and then let us switch over to aromaticity, the concept of aromaticity, and then we are going to see the rules to predict the aromatic compound. Let me say a few words about aromatic compound. When we look into the aromatic compound, they contain alternate single and double bonds in a cyclic structure, and the majority it resembles the benzene in its structure. Also, when we look into the chemical properties, even though it contains a double bond, it resists addition reactions. Rather, it undergoes substitution reaction. So, aromatic compounds behave uniquely. So, we are going to study it in a separate content in the organic chemistry. So, what is aromaticity? Let us see about it. Aromaticity is the property of the sp2 hybridized carbon in a planar ring structure. Okay, so before that, let me point out, it resembles benzene-like structure that I said already. So, in benzene, so 6 carbon atoms are in a cyclic manner with the alternate single and double bonds. All the carbon atoms are in sp2 hybridized, and it contains one unhybridized p orbital in each carbon atom. Okay, so aromaticity is the property of the sp2 hybridized planar rings in which the p orbitals allow, that is unhybridized p orbitals allows cyclic delocalization of pi electrons. So, this is the concept of aromaticity. Definition for aromaticity. So, here in each carbon atom, the unhybridized p orbital is there. They are in a position to overlap sidewise to form a pi bond. Okay, so delocalization of pi electron is there. Whenever delocalization of pi electrons in the cyclic structure, the concept may arise. This aromaticity concept may arise. So, let me switch over to the criteria for aromaticity. So, let me point out the rules to predict the aromaticity of the compound. Rule number 1, an aromatic compound, it must be a cyclic and planar. All the atoms involved in the cyclic structure should be in a plane. So, it should be cyclic and planar. Rule number 2, each atom in an aromatic compound should possess unhybridized p orbital. All the unhybridized p orbitals in the cyclic structure should be parallel. Then only a continuous overlapping is possible around the ring. Rule number 3, the cyclic pi electron cloud then overlap sidewise. So, that overlapping leads to overlapping leads to double bond. The pi electrons involved should contain 4n plus 2 electrons, where n is the integer. It starts from 0, 1, 2, 3, etc. So, this is the rule of Huckel. This is the rule framed by Huckel to predict the concept of aromaticity. That is 4n plus 2 rule. So, let us apply these rules to predict the aromatic compound for the particular examples. These examples are to be dealt one by one in detail. First, let us see benzene. Benzene, according to the first rule, the aromatic compound should be cyclic and planar. So, we are going to predict whether this benzene is, even though we know benzene is aromatic compound, we are going to apply these two rules, that is criteria for aromaticity to check whether that benzene is aromatic or not. So, according to the criteria of aromaticity, rule number 1, it should be cyclic and planar. So, look at the structure of benzene. It is cyclic as well as all the carbon atoms are in the plane. So, it is cyclic and planar. And it has p orbital on each carbon atom, leading to delocalization of the pi electrons. Rule number 2, that is also satisfied here. According to the rule number 3, here totally how many double bonds are there? 3 double bonds. Single double bond of 2 pi electrons, so totally 6 pi electrons are there in benzene. So it obeys Huckel rule when n is equal to 1. So according to Huckel's rule, 4n plus 2 pi electrons, if 4n plus 2 pi electrons are in the compound, that must be aromatic. So 4n plus 2, that means if you put n is equal to 1 there, 4 into 1. So 4 plus 2, that is equal to 6. So 6 pi electrons are there in benzene. So it is aromatic in nature. So next example we are going to say is naphthalene. So this is the structure of naphthalene. So here 2 benzene rings are in a fused fashion. So it's a condensed ring system. So it has 5 double bonds. On viewing this structure, it has 5 double bonds. So 5 into 2, totally 10 pi electrons are there. Okay. So we have to check according to Huckel's rule whether this 10 pi electrons containing organic compound is aromatic or not. Okay. So let us start from the criteria 1, that is rule number 1. It should be cyclic and planar. When we look into this compound, it is cyclic and it is planar. All the carbon atoms, here naphthalene, it contains 10 pi electrons. So all the 10 carbon atoms, all the carbon atoms are in the plane. So it is cyclic and planar. According to the rule number 2, each carbon atom has one unhybridized p orbital, leading to the delocalization of pi electrons by sidewise overlapping. So according to the rule number 3, it obeys Huckel's rule, that is 4n plus 2 pi electrons. Here it contains 10 pi electrons. When we put n is equal to 2 means 4 into 2, 8, 8 plus 2, 10. So 10 pi electrons containing organic compound that obey Huckel's rule. So this compound is an aromatic compound. So next example, that is cyclobutadiene. So when we look into this example, it is cyclic and planar. Here 4 carbon atoms are there. It's a cyclic structure. All the carbon atoms are in plane and all the carbon atoms contain one unhybridized p orbital, leading to delocalization of pi electrons. But according to the rule number 3, it does not obey Huckel's rule because it contains 2 double bonds. So totally 4 pi electrons are there. So the compound with 4 pi electrons, it does not obey Huckel's rule. So this compound, that is cyclobutadiene, is not an aromatic compound. It is non-aromatic compound. The last example that we are going to deal is cyclooctatetraene. It is a cyclic structure with planar geometry. Here 8 carbon atoms are there. All the carbon atoms are in the plane. It's a cyclic structure, and each carbon atom has one unhybridized p orbital, which are parallel to one another, leading to the complete delocalization of pi electrons. Okay, according to the rule number 3, it does not obey Huckel's rule since it contains 8 pi electrons. So totally here 4 double bonds are there. So 4 into 2, that is 8 pi electrons are there in cyclooctatetraene. So the compound with 8 pi electrons does not obey Huckel's rule. So n must be integer. When you put n is equal to 0, 1, 2, 3, so the number of pi electrons for an aromatic compound, it must be 6, 10, 14, etc. Here it contains only 8 pi electrons, which conveys us that it do not obey Huckel's rule. So let us summarize today's talk. For a compound to be aromatic, it should be cyclic and planar. It should contain delocalized pi electron cloud with alternate single and double bonds, and lastly it should obey Huckel's rule. When the when an organic compound obeys all these criteria, it will be aromatic. Let us see in the next video with some more examples regarding this aromatic compound. Thank you.